All right, here we are back, and we're going to be adding and subtracting rational expressions. So last video we were multiplying and dividing. Now we're going to do a little adding and subtracting. So let's get it started. All right, so we remember when we're dealing with fractions, we need common denominators. So here I have 1/8, 1/4, 1/5. So we always want to look for the least common multiple between these three numbers on the bottom. Okay, so let's see here. Well, 4 and 5's least common denominator would be 20. 8, though, doesn't go into 20, so it looks like my least common denominator, or so my least common multiple between these things is going to be 40. All right, so in order to get to 40, means I'm going to be multiplying the 8 by 5. So multiply both the top and the bottom by 5. Multiply both the top and the bottom here by 10 to get to 40 from 4, and multiply the top and the bottom by 8 in order to get to 40 on the 1/5. So it looks like then we're going to have 5/40ths plus 10/40ths plus 8/40ths, and it's going to get me 23/40. And now I've added up all of my fractions. Okay, so this same concept is going to work even as we add towards variables. So here I have three denominators, x, 2x squared, and 3x. So when you're looking for this, for the least common multiple, we want to know what does this have that this doesn't, and vice versa. So I have an x, here's a 2x squared, so I would need a 2x to be multiplied here because I would need another x to make x squared, and a 2. And then, so this 3 doesn't have any of that, so that would be 2x squared. And this needs a 3, and this needs a 3. So it looks like my least common multiple is 6x squared. Okay, so I'm going to do 1 over x, so that'll be times 6x. So I need 6x squared plus 1 over 2x squared. So I'm going to multiply this thing by 3 top and bottom. And I'm going to multiply the last thing by the 2x squared to get 6x squared in the denominator. So therefore I would get 6x over 6x squared plus 3 over 6x squared plus 2x squared over 6x squared. All right, so now when we're adding up, we want to still keep to our like terms. So here we have 6x, 3, 2x squared. None of those are actually like terms, so they just stay. So I get 2x squared plus 6x plus 3 all over 6x squared. And that is going to be my final answer. Because remember, those x's do represent a number value. So eventually we would add this all up and get a fraction that looks like this. But we don't know what the x squared or the x are, so we just have to leave it as 2x squared plus 6x plus 3. Okay? Sometimes we have whole polynomial functions. Now, what you want to look over here is do not just add 5 to this or add -1 to this. X minus 1 is one whole term. X plus 5 is one whole term. So both of those, so here you have 2x over x minus 1. So this needs an x plus 5 to be multiplied next to it. So x plus 5. And then plus this needs an x minus 1. So that's going to be multiplied by 3 all over x minus 1 times x plus 5. All right, so now I'm going to get 2x squared plus 10x all over x plus 5 x minus 1 plus 3x minus 3 all over x minus 1 x plus 5. And you don't need to multiply out the denominator, you can just leave it just like that. And now we're just going to combine our like terms. So here I'd get 2x squared plus 13x minus 3 all over x minus 1, x plus 5. And there will be my final answer. And again, the only reason we multiply out the top is so that we can combine our like terms. The denominator is just going to stay the same denominator every time, so it's not necessary to multiply that thing out. You can do it if you want to, but it's not necessary looking at it. All right, let's try another one. Okay. All right, here we have something that looks a little bigger and nastier. So the key thing that always helps when we're starting our rational expressions is to always factor it. So I'm going to factor this out and make this 2x minus 1, make this 3x, let's see, 3x plus 4, okay, so 3x plus, looks like 4 would be 4 and 1. Let's see what we got here. Okay, so we know this is going to be 3x and x. 4 is either going to be 4 and 1 or 2 and 2. 3 times 2 is 6, and 2 times 1 is 2. 6 and 2 do not add up to 13. So maybe it's got to be 4 and 1. 3 times 4 is 12. 1 times 1 is 1. It's got to be that. All right, so we got 3x plus 1, x plus 4, plus x plus 3, all over, sorry, it's a bad plus sign, x looks like minus 7, and x plus 4. Okay, so both of these have an x plus 4, but this one's missing a 3x plus 1, and this one's missing an x minus 7. So I'm going to then multiply that on each one. So my common denominator, so we get x minus 7 times 2x minus 1 all over 3x plus 1, x plus 4, and x minus 7. And now I'm going to add that to 3x plus 1 times x plus 3 all over 3x plus 1, x plus 4, x minus 7. Whew, okay. All right, so I'm going to have a big term on the top, but my denominator is going to be 3x plus 1, x plus 4, and x minus 7. All right, so multiplying this out, I get 2x squared. Here I get negative 14x, and negative 1x is negative 15x plus 7. All right, and I'm going to add that to 3x squared plus 10x plus 3. All right, so my final answer over 3x plus 1, x plus 4, and x minus 7 is going to be 5x squared minus 5x plus 10. And that is my final answer of those expressions added together. Okay, so the key thing is always factoring it out, multiply it through, then combine your like terms. Okay, and the real key here is not looking at this and just saying, oh, I need a negative 7, or I need a, I need a 3x over here. These are all single terms, so you list the factors right next to each other. It's looking at like, what am I missing in this fraction? All right, let's try one more. Ooh, now we got a subtraction one. So the only difference in the subtraction is that we just have to watch our negatives. So here we have x plus 4, okay, minus 4x minus x squared. I'm going to leave this multiplied out, even though I normally would like to factor it. And here I get x plus 4, x minus 4. Okay, so this has an x plus 4, and this has an x plus 4, but this has an x minus 4, and this one doesn't. So I'm going to multiply both top and the bottom by x minus 4. So I get a common denominator, and here I get 2x minus 8 all over x minus 4x plus 4 minus 4x minus x squared all over x plus 4 x minus 4. All right, so you got to remember you are subtracting this whole numerator. Okay, so this negative gets distributed to both terms. So this is going to be 2x minus 8 minus 4x plus x squared, because I am subtracting both those terms over x minus 4, x plus 4. All right, now we just need to simplify it out. 2x minus 4x, so I'd get x squared and minus 2x minus 8 all over x minus 4, x plus 4. All right, and it looks like I might be able to factor something out. So actually at the beginning, if I would have taken out an x, I might have been able to actually see that. But, you know, it's okay to do it at the end. So here I get x minus 4 and x plus 2 all over x minus 4, x plus 4. And look, I get a minus 4 that cancels out. So my final answer is actually x plus 2 over x plus 4. So do look at the end if you can take things out and let every, you know, if you can factor out a whole, do that. And then you're stuck with your regular rational expression that's in its most simplified form. All right, so hopefully that gave you a little taste of what adding and subtracting is. We'll do a lot more practice in class. And as always, ask your teacher if you need extra help. And then we'll be back to do a little rational exponents after your test.